Hello everyone, I am Peter B. Haddad. I am a third year engineering physics student at IIT Roorkee. I am here to explain about the working of light dependent resistance. Definition. So a light dependent resistor, also known as a photoresistor or a photocell, is a type of passive electronic component that exhibits a change in the resistance based on the intensity of light falling on it. The construction of an LDR involves a semiconductor material with light sensitive properties such as cadmium sulfide or cadmium selenide, which is sandwiched between two electrodes. So these electrodes provide the electrical connection necessary for the LDR to be incorporated into an electronic circuit. Working principle. The working of an LDR is based on photoconductive effect, wherein the electrical conductivity changes when exposed to light. When photons strike the surface of the semiconductor material, they excite electrons within the material, which causes them to move from the valence band to the conduction band. This process creates mobile charge carriers, electrons and holes, and thereby increases the material's conductivity and reduces its resistance. Conversely, in low light conditions or darkness, the absence of photons results in fewer excited electrons and reduced conductivity in the semiconductor material. As a result, the resistance of the LDR increases, and this restricts the flow of current through the device. Circuit diagram. So here is a circuit diagram for LDR. So when the power is on, the current starts flowing in the circuit through the LDR. The resistance of the LDR depends on the light intensity falling on it. There is a provision to change the applied voltage with the help of a knob. The current through the circuit and the applied voltage are shown in the display. So now let's see the procedure for the LDR characteristics experiment. Uh, so, we have the cadmium sulfide, the photosensitive material. So the resistance of this material varies depending on the amount of light intensity that falls on it. Then this is the voltage knob, so which is used to change the voltage. So and we measure the voltage between these two points, which is displayed on this here, and the current that is passing through the circuit is also shown in this display. Now let's see how the experiment is being done. We do it by varying the distance between the light source and the cadmium sulfide at a particular interval. We can see as the distance is increased, the current through the circuit is decreased. Observations. So these are the set of readings we got from the experiment, fixing voltage at the fixed value of 2 volt. We have also computed the inverse of distance squared and using voltage and current to reduce the resistance. On the right hand side, we have plot a graph taking 1 by r square, which is proportional to intensity as the x-axis and resistance as the y-axis. We can see that the resistance is decreasing as the intensity is increasing in the form of a hyperbola. Here I have mentioned some of the important applications of LDR. First one is light sensing. So LDRs are essentially used in light sensing applications such as automatic street light control system. They can detect ambient light levels and trigger the switching on or off of lights accordingly. Second, camera exposure control. The LDRs are used in cameras to adjust exposure settings. They help the camera determine the appropriate shutter speed and aperture size based on the available light. Security systems. LDRs are integrated into security systems for detecting changes in light levels. They can trigger alarms or activate cameras in response to sudden changes in ambient light, indicating potential intrusion or unauthorized access. Solar panels. LDRs are employed in solar panels to track the position of the sun by sensing the intensity of sunlight. They help optimize the orientation of solar panels for maximum energy absorption. The automatic day or night mode switching and brightness control are other important applications utilizing LDR. Let's we look into the advantages and disadvantages of LDR. First we mentioned some of the advantages. So high sensitivity. The LDRs exhibit at high sensitivity to changes in light levels, allowing them to detect subtle variations in ambient light. And the passive operation. And the LDRs operate passively without the need for an external power source, or complex control circuitry. The wide dynamic range. The LDRs can detect a wide range of light intensities from low light levels to bright light conditions. Then the low cost and simple construction is another advantage. So next we see some of the disadvantages. The slow response time. The LDRs typically exhibit a slow response time compared to other light-sensitive devices such as photodiodes or phototransistors. And the nonlinear response. The resistance of an LDR does not always change linearly with the changes in light conditions. This nonlinearity can introduce inaccuracies in applications where precise light measurement is essential. And temperature dependency. The resistance of an LDR is not only dependent on light intensity, but also on temperature. Variations in temperature can affect the accuracy and reliability of light measurements. The limited spectral response. The LDRs are sensitive to visible light, but may have limited sensitivity to certain wavelengths or colors within the electromagnetic spectrum. This limitation can restrict their use in applications that require detection of specific light wavelengths or colors. Susceptibility to environmental factors. LDRs can be sensitive to environmental factors such as humidity, dust, and ambient light sources other than the one being measured. Conclusion. Application-specific considerations. When using LDRs, it is essential to consider factors such as response time requirements, accuracy limits, and environmental conditions to ensure optimal performance in specific applications. Complementary technologies. While LDRs excel in certain applications, they may be complemented by other light sensing technologies like photodiodes or phototransistors for applications requiring faster response time or higher precision. In conclusion, the light-dependent resistors (LDRs) offer a cost-effective and versatile solution for various light-sensing applications, providing high sensitivity and wide dynamic range. Understanding their characteristics and limitations is essential for effectively incorporating them into electronic systems and achieving desired performance outcomes. Finally, thank you everyone for joining me in this presentation.